Добрый вечер, привет, I think. Today I would like to talk to you about web components and a new experimental JavaScript API called the Accessibility Object Model, or AOM. Before I do that, though, a reminder about how accessibility mechanics work in the browser. When we put an HTML document into the browser does several things with that information. It takes the HTML and it creates a document object model, the DOM. It also creates a parallel structure called the accessibility tree, and it creates other things like a visual appearance for the element if it needs one, and if it has interaction, it provides the necessary keyboard and mouse and touch support. So the browser does a lot for us when we just use HTML as it was originally meant to be used. If we take an example, the button element, my second favorite HTML element, our HTML code would look like this. I'm sure you all are familiar with how the button element looks in HTML. The browser creates the DOM, and it looks exactly the same as our HTML. It's a complete duplication of the button element in HTML. And it's this, of course, that we can use to manipulate with JavaScript and add functionality. If we use a click mouse event handler, the browser will automatically provide the keyboard support necessary to use it as well. So it's very simple and self-contained. The accessibility tree for that button element would have 2 or 3 pieces of information associated with it. It will say that the element has a role of button. That's how an assistive technology like a screen reader knows what this element does, and it will use that information to tell the user it's a button. And then the user knows that it's a button, so they're supposed to interact with it. In this case, our button has play as its text, perhaps because it's the play button in a video player or an audio player. And that becomes the button's accessible name. That's how a screen reader knows how to tell this button apart from other buttons that might exist on the same document. And lastly, the accessibility tree says that this element is focusable, which means if you use a keyboard and you use the tab key to navigate through content, you can focus on this button in order to interact with it using either the space or the enter keys. The UI, with a bit of help from some CSS, might look something like this. We get a play button on screen, and hopefully it looks like you can interact with it. The problem is that a button on its own doesn't do very much. And I think it's missing one pretty important feature, especially in this case. When you press a play button, what you want it to do is to start playing your audio or video. And that means you need to indicate that the button has been pressed, that you've successfully hit the button and something is happening. The button element doesn't have any notion of a pressed state. Radio buttons can be checked, checkboxes can be checked, but buttons in HTML can't be pressed, which seems like a bit of a missing thing to me. So enter web components, or to be more specific, custom elements. Web components, if you're not familiar, is a term that's used to mean 3 different specifications: custom elements, the shadow DOM, and HTML templates. In this case, we're going to look at custom elements, and there are 2 sorts of custom elements that you can choose from. The first we'll look at is called a customized custom element. And you start by taking an existing HTML element and adding behavior to it. So on screen, we can see the constructor that takes the HTML button element and extends it to create a custom element called toggle-button. All custom elements must have a dash in the middle of their name. It's just a very simple way to let browsers know this is a custom element, not a native HTML element, and also it makes it easy for people to tell the difference too. So we'll take the button element and we'll create a custom element called toggle-button. We'll use a connected callback to add in a little bit of ARIA. If you've not come across it before, ARIA stands for Accessible Rich Internet Applications. And it's a way of adding accessibility information to elements, or when you create entirely new elements, giving them the accessibility information that we saw just now in the example of the accessibility tree. In this case, we've got all the accessibility information, the role, the name, and the state that we get from the button element. So all we need to add is the idea of when this button has been pressed. And there's an ARIA attribute for that called ARIA-pressed. So all we're going to do in our connected callback is just set that attribute to false, because when the media player interface first loads, we don't want that button to be pressed. And we're just going to attach some simple functionality to it. When someone clicks on the button, we're just going to toggle the state of that attribute to true, which will show that the button has been pressed. And when we press the button again, it will toggle it back to show that it's no longer pressed. And we can see that there in the function. It's just really simple. The nice thing is that because we're starting off using a button element and we're extending it, we don't need to worry about keyboard support. If you remember, I said the browser provides that automatically when we add in click support. So we've done that. The browser will give us the keyboard support. And our HTML, when we want to use this new element, will look like this. Now, this is where things start to get a bit of a problem with customized custom elements. You don't actually create a whole new element. What you do is you add another attribute to the element you're extending. So we use the same HTML button element, but this time it's got is toggle button added to it as an attribute. Now, a lot of people don't really like this syntax. They say it's ugly, it adds clutter to your code, it's extra attributes where we don't want them. That's certainly one problem with a customized custom element. Another bigger problem is that WebKit browsers don't support them. So if you need to support Safari, and certainly on mobile, that's a big part of the audience, then unfortunately customized custom elements are probably not the route you want to go. But just to finish telling this story, we see something else in the DOM. As well as seeing the button element and the is attribute, we also see that ARIA-pressed attribute come through. And this is one of the problems I'll come back to a bit later on in the talk. Why do accessibility attributes like this leak into the DOM when we've added them inside a custom element? The accessibility tree also changes a little bit for our toggle button. By adding the ARIA-pressed attribute to the button element, we've changed its role. It's not a button anymore, it's now a toggle button. And a screen reader will get hold of that information from the browser and understand that this button is intended just to be toggled on or off. The accessible name is still the same, it's still the label inside the button element. And the state initially is still the same. This can be focused on with a keyboard. If we press the button, though, that accessibility tree will add some more information. It'll also say that the state of the button is pressed, which is pretty much what we wanted to achieve with our custom element. When a screen reader comes to the browser and sees this button is toggle button code on the page, the screen reader will ask the browser for the information that's contained in the accessibility tree, and it will tell the user what they're interacting with, like this.
Play toggle button not pressed. Pressed. Not pressed.
So now they're told it's a toggle button. So as I said, that sets up the expectation that you can toggle this button on or off. And the screen reader user now knows when it's been pressed or when it's not pressed, which visually is also obvious. But if you're a screen reader user, it's likely that you can't see the screen. So this information makes the button much more accessible. You know whether you're playing something or not. So it's really nice and simple. But as I said, there is a problem with customized custom elements. The other kind of custom element is an autonomous custom element. This doesn't let you take an existing HTML element and extend it. You have to start from the beginning by extending the HTML element. Now, this means that as developers, when we create a custom element that's autonomous, we have to do all the work that the browser used to do for us. So it's much more to do from a development point of view. So we take the HTML element and we extend it again, and we'll again create a custom element called a toggle button. Our connected callback looks a little bit different this time, though. We have to, as I said, do all the hard work that the browser used to. So we have to tell the browser that this element now has a role of button. just set attribute, role button. We have to use the tab index attribute with a value of 0, because that will make this element focusable with a keyboard. We also do what we did before and add in the ARIA pressed attribute so that this button, our toggle button, has an idea of state. We have to do even more work though, because this time we have to not only provide click behavior, but we also have to provide the keyboard behavior as well, which means we have to listen for the space or enter keys. That's the key codes 13 and 32. And when either of those is detected, or a mouse click, then we do whatever the button is supposed to do. In this case, it will toggle the pressed state and presumably begin playing something in your media player. Our HTML looks a lot cleaner. We actually get to use a toggle button element, which is pretty much what we wanted to do in the first place. So that's definitely a good positive thing about an autonomous custom element. The DOM gets a lot messier, though, unfortunately. We see all the attributes that we've just added behind the scenes. We see the tab index, we see the role, we see the ARIA pressed. No is attribute this time, but there's a lot of extra code in there. And again, that makes some people very unhappy. And again, we'll come back to that in a little while. The accessibility tree looks exactly the same, though, as it did with our customized custom element. We have a toggle button. That's what the button is and what it does. Its accessible name is still play. That's how the screen reader announces it. And the state is still focusable by default and will show that it's pressed when the button's been pressed. And so our demo sounds remarkably like the previous one.
Play toggle button not pressed. Pressed. Not pressed.
So an autonomous custom element gives us a real custom element. Its HTML is very neat and tidy. The accessibility information is there. We have to do some more coding as developers, but it does all work and it is all quite possible. And the end result is an accessible play button, which is good news. We still have the problem, though, of all those attributes all over the place that we didn't really want. And this is one of the problems that the accessibility object model, the AOM, intends to solve. I said at the start, this is a new, very experimental JavaScript API. It's being developed at the W3C in the Web Platform Incubator Group by people from Google, Apple, and Mozilla. And the AOM has several different phases of things that it wants to solve. Phase 1A is ARIA attribute reflection. So most HTML attributes have two parts to them. They have a content attribute and a web interface definition language, or web IDL counterpart. And with almost all attributes, if you set the content attribute, i.e. if you put the attribute into your HTML code, the IDL attribute automatically gets updated, which is the process we call reflection. If we set the content attribute in our HTML, the IDL attribute reflects the same information. But not all attributes can do this, and ARIA attributes are one of the kinds of attribute that don't do this reflection. And this is what the AOM intends to solve. So the way they've done it is to add two mix-ins to the ARIA 1.1 specification, 1.2 specification, which is available now and will be an official W3C recommendation probably early next year. It adds accessibility role, which is the mix-in that allows the reflection on the role attribute, and accessibility attributes, which is the mix-in that allows reflection of all the other ARIA attributes, like ARIA pressed. So one thing that this does is changes the way that we can write ARIA into our custom element. We don't have to use the set or get attribute methods anymore. What we can do now is rewrite our connected callback to use syntax that's more like this.role equals button, or this.ARIA pressed equals false. And you'll notice that the ARIA pressed attribute has changed a little bit. It doesn't have a dash in the middle anymore. It's just all one word, ARIA pressed in camel case. So this makes writing ARIA very much more familiar, especially to most of us who write JavaScript. And it also means that we can do this now and set the IDL attribute and have it reflected back to the content attribute. So ARIA reflection, or reflection of ARIA attributes, is now complete. And the good news is that implementation for this is already pretty good. If you use Safari, it's shipping already. And if you use Chrome, it's available behind the flag. Firefox, I believe, is watching this, and I hope we'll have it implemented before very long. If you're curious, there are web platform tests that you can visit. The URL on screen, if you go to it in Safari, you will see the test results. There's 106 tests at the minute, and Safari passes 86 of them. If you enable the accessibility object model flag in Chrome and do the same, you'll see that it too passes, I think, 82 out of 106 tests. So that's a quick way to keep track of the ARIA reflection state of support at the moment. There is a second part to phase 1A, and that is reflecting element references. At the moment, some ARIA attributes, like ARIA owns, or ARIA labeled by, or ARIA described by, point to the ID value of another HTML element on the page. Now, ID values have to be unique within a document, and that causes two problems. One slight problem, which is that when you have a simple page, making sure you have unique IDs is not too much of a problem. But when you're developing a very complex web application, auto-generated ID values, often hundreds, sometimes maybe thousands of them in the same document, then ensuring that they're all unique can be a really difficult thing to do. Take a look under the hood of an application like Gmail in the browser if you want an example of how terrible this can be. A much bigger problem is that when we use the shadow DOM inside a custom element, the IDs that are inside the shadow DOM are scoped to the shadow DOM, which means that if we were to use the shadow DOM with our toggle button, any ID that we might put inside it is unique to that particular button on the page. Even if we had 10 examples of our toggle button on the same page, those 10 ID values, even though technically they're all the same, would behave as though they were completely unique. And so that makes cross-boundary referencing for ID values really difficult. And this is what this element reference reflection hopes to solve. Now, hopes because this isn't yet supported. There are some pretty difficult problems that need to be solved before that can happen. But when it does, we'll be able to write code like this. We will be able to reference objects by name in the JavaScript rather than their ID reference value. So when the time comes and support for this actually happens, it will make referencing objects a lot easier from JavaScript, and certainly it will help solve the cross-boundary problem with referencing ID elements inside the shadow DOM. Phase 1B wants to add custom element semantics. So there are two ways that they want this to happen. One is that when a custom element is instantiated, when it's added to the page, they want all the accessibility information to be put in place right from the very beginning. The other option is that each time a custom element is used, we can alternatively set up its internals, which is a simple way of saying we want to do what the browser is already able to do. If you think back to our button example, when we looked at it in the DOM, there was no sign of the CSS that rendered it on screen. There was no sign of the tab index attribute to make it focusable, or any of the other attributes that we had to add in our autonomous custom element example. And it's this encapsulation that these semantics want to try and accomplish. So one option, as I said, is for default semantics. So we can add it to the definition of our custom element. So we just define the accessibility properties of the button element when we define the custom element itself. In this case, that it has a role of button, it has a tab index of 0 to make it focusable, and the ARIA pressed attribute can be set. So that's one way of doing it. The other will be to do it on a per instance basis. So if there are variations on an instance, you can just create the internal properties of that element pretty much the same way. We can just add in the button role, the tab index, and the other accessibility properties. And when this is possible, this will solve the problem of all the attributes leaking out into the DOM. So when we use our toggle button custom element and we look at it in the DOM, we won't see any of the ARIA press, the roll button, none of those attributes at all. We'll just have nice, clean DOM that, like the original button element, is an exact representation of the HTML element. But this is all still to come, unfortunately. Phase 2 will add the ability to listen for events from assistive technologies. At the moment, as you know, we can listen for events from different devices, whether it's a tap with a finger, a press of a particular key, or the click of a mouse. What we can't do is listen to events that are unique to assistive technologies. So at the moment, to protect privacy, some things already happen. When someone taps on something or presses a key, often it simulates a click event. But one that will be added is that when somebody using keyboard focuses on something, it will synthesize a focus event. The idea is that it shouldn't be possible to detect that someone is not interacting with the content in a pretty standard way. So, sorry, there we go. They're also going to add some new events, and this is where it gets really interesting. They're going to add events that will detect when an assistive technology like a screen reader is running and someone uses the gesture that shows either increment or decrement or page scroll up or scroll down. And it's the first of these that is the really interesting solution to a very real problem. If you create a slider, a custom slider now using divs and spans and JavaScript, CSS and ARIA, you can't use it on a touchscreen phone when there's a screen reader running. And that's because the gesture to increment or decrement, flick up or flick down, is already being used by the screen reader to do something completely different. And there is no way to pass that gesture back through to the slider and say, hey, don't use it for the screen reader, use it to interact with this slider. Now, there are ways to solve this problem, and I'll show you a link to one at the end of the talk, but it's a really hard problem to solve. It involves a lot of hack coding. Nobody likes the way it works, and the idea is that if the AOM reaches this point, it will solve that problem. You'll be able to, with your JavaScript, detect when someone with a screen reader is flicking up or flicking down to increment or decrement something like a slider. Now that in itself introduces privacy concerns because as a JavaScript developer, as the person who runs the website, as an advertising person with JavaScript running in your advertising campaign, you will be able to tell that someone is using an assistive technology, and quite likely that that assistive technology is a screen reader. And if you know that, you can reasonably conclude that the person who is using your content is blind or low vision, visually impaired in some way. So with this technique comes the very real possibility that we'll be able to fingerprint that a person has a disability. And that represents a very big privacy security concern and one that will need to be solved before the AOM succeeds in implementing these changes. Phase 3 is all about virtual accessibility nodes, and this is where things get really interesting. At the moment, the accessibility tree is created by the browser. It looks at the HTML, looks at the DOM, and then creates the accessibility tree. With this phase of the AOM, we will have the opportunity as developers to add and take away and change things in the accessibility tree for ourselves. So we won't need to go via the DOM at all. We won't need the browser to do anything. We'll have the complete ability to change and update the accessibility tree for ourselves. Think of it, if you like, as a shadow accessibility tree. It won't exist in the DOM or the light DOM, but it will exist in the accessibility tree. Now, this is both exciting and terrifying all at the same time. It's exciting because it gives us an opportunity to solve another big problem. The canvas element is a good example. When we use the canvas element, we write pixels to the screen. There's no semantic information, there's no HTML involved, there's nothing from an accessibility point of view that can be used by a screen reader or any other assistive technology. With this ability to add trees into the accessibility tree, we could create entire branches of the accessibility tree that are just for fallback content for screen reader users for the canvas element, which does solve a problem. mostly. It only solves that problem for screen reader users. If you happen to be a sighted keyboard user, you're still going to be out of luck. That canvas element is still almost certainly going to be inaccessible to you. But this is a small piece of a big puzzle, and an interesting one. It's terrifying because it also runs the risk of having an accessibility tree that bears no relationship at all to the DOM and what everybody else is looking at on screen. And that kind of separation is pretty risky. I know, as someone who doesn't see, that often I will refer to something on screen. I'll say, that heading, that button. And if it's hidden, the sighted person I'm talking to, what button? What heading? And here, with this, we have the ability to do that on a really grand scale. So it's something we will have to use with great responsibility, I think, if the opportunity comes and the AOM gets to this point. Phase 4, the last one, is that we'll have access to the computed accessibility tree. Pretty much the same as we have access to computed styles, for example. We'll get access to the computed accessibility properties for an element. So we'll have an easy way of understanding what's been inherited in terms of accessibility properties. We'll also have the opportunity to walk the whole of the accessibility tree, exactly as we can walk the whole of the DOM if we want to. So this too has some interesting capabilities. It means we could, for example, look for all the buttons on a page and do something in accessibility terms with them. And that has some pretty exciting possibilities too. But this is all in the future except for the first bit. And returning to our toggle button element, toggle button is all very well, but so far at least our particular example hasn't done anything particularly exciting. And there's more to web components than just custom elements. So if we take our toggle button and we change it slightly, we'll create a completely new custom element called speak content. This time in our HTML, we'll use the speak-content element, and inside it, we'll put two elements that act as slots, and we'll fill those slots in a little bit later with something using HTML templates. What this button is going to do is it will turn the first slot into a button, and it will say speak this as its label, its accessible name. And when you press it, all things being equal, it's going to speak the content that's inside the second slot using the web speech API, another, to me at least, interesting JavaScript API that we have at our disposal. So let's see how this all can work. We're going to use the shadow DOM. I mentioned this earlier. So we're going to attach a shadow root inside our custom element, and we're going to clone the contents of an HTML template into that shadow root. Here we've also defined that HTML template. We've put a style element in there. It's empty at the moment, but it will contain our CSS so that the way this button looks, its CSS properties, are encapsulated inside the button element, just like it is with a real element. We also set up what will take the place of the two slots in our HTML. The first one will become an actual button, and we'll use that to control our speaking content, and the other becomes a div that contains the content. In our connected callback, we just set things up so that we attach the item that has the shadow root, and we give it to the variable of a control so we know what we're dealing with. We set things up so that we grab the contents of the div that is what we want the web speech API to speak, and we hook it all together, as I say, using the web speech API. To do that, we create a speech synthesis utterance, This is the speech object using the web speech API, and we tell it what we want it to speak. We basically tell it to speak the content of the div that's in our HTML. We're also going to keep that toggle behavior in our button so that when someone presses and this custom element begins to speak, the pressed state of the button will be set. And we're going to leave it set for about 5 seconds, and then we're going to do something else because the speaking may carry on going for longer than that wait period. So all we're going to do is just every now and again, when the time runs out, check again. If the speech synthesis object is still speaking, if that returns true, then we'll just reset the timer and wait for another 500 and then check again. And if there's nothing speaking, then we'll just reset the button back to its unpressed state. I mentioned the CSS. We're going to do something here, which is a trick I learned from Hayden Pickering. And he came up with the idea of tying your CSS properties to the state of your ARIA attribute. So in this case, when the ARIA pressed attribute is set to true, it changes the style of the buttons, and vice versa. When it returns to being set to false, the styling changes again so that visually the button looks pressed when its accessibility state says it's pressed and doesn't look pressed when it isn't. And this is useful for two reasons. It makes sure everything works well together. It also means that as developers who are sighted, it's a very easy way to check when your accessibility isn't working. If the style of your button doesn't change and your styles are associated with the state of your ARIA attribute, it probably means that your ARIA attribute isn't behaving in the way that you thought it would. So it's a very easy visual way to debug potential accessibility problems, which I like, because debugging is important. So what happens with all of this is that when we use that HTML with the two slots, we see this on screen. We get a button and some content that we want it to speak. And if you were to come along with your mouse, no screen reader this time, this is what would happen.
1 tequila, 2 tequila, 3 tequila, floor.
Now, I dare say that you would probably want to use this to read some actual proper content, but that seems like some pretty good content to me. I don't know. So that's me done on an introduction to web components and the accessibility object model, and a quick example of some fun that you can have when you bring web components and other bits and pieces together to create something hopefully useful. I need to say thank you to the people on screen, Scott O'Hara and Dan Hopkins, for answering all my crazy questions as I was writing this talk. Patrick Lelka also for doing the same. And there is the URL of the custom slider that I mentioned that does get around all the problems that the AOM would like to solve if you need a production version that's ready now. Thank you very much. Спасибо.
So let's
Okay.
let's answer some of your questions.
Mm-hmm.
Yep.
Ooh.
Let's
Yeah,
step
got it.
further.
Mm-hmm.
Yep. Almost
Thank you.
there.
Спасибо.
Right. Thank you for a great talk.
Thank you.
We have a number of questions. Most of them are asked in English. So thank you guys and girls for asking them in English. So what do you think is the biggest problem with spreading accessibility first approach to web development? What halts web development from implementing these features in their projects?
For accessibility.
Yeah, the biggest,
generally?
Yeah, the accessibility approaches in general, because it's definitely not default these days.
I think the biggest problem is that we don't really know how to do a lot of this. We're not taught it in college. A lot of blog posts, online articles, tutorials don't tell you how to do this stuff just by default. And so it seems scary. I've met many developers, designers, UX people. They want to solve this, but they just don't know where to start. If they knew where to start, they would do it, just like we do all the rest of the things that we do without thinking about it. So I think, yeah, knowledge is the big problem.
All right. You were focusing on custom elements on your talk, because that's one of the problem you were trying to solve. But is it something mandatory for having a good accessibility in your project, or is it just an example?
You don't. Sorry, do you mean a custom elements mandatory?
Yeah.
No,
if it's something that's good for accessibility or bad, or yeah,
just the same.
Yeah, so it was just a use case,
right? Yeah, I mean, almost all of the ARIA, the other things I talked about, you can use those now when you create things with divs and span elements. It doesn't need to be a custom element.
All right.
So yeah.
Why would Gecko and WebKit agree on web accessibility standards, so it would be easier for us to apply those principles to our code. So I guess there someone from audience seeing the problem, the biggest problem in browser implementations.
That's a very good question. Apple do not like to discuss why they choose to do things. I believe the reason is that they don't like the is attribute syntax, and that is enough for them to say, if that's the solution,
All right.
we won't support it. But that's my guess. I don't know.
But do you remember what were their arguments against it, or they just said we don't like it? Period.
I recall that they said they didn't like it. I think there was more good reasons to it. You would have to go and find the GitHub issues now to
dive into GitHub issues or email.
GitHub issues.
GitHub issues. Okay, that's better.
Yeah.
All right. Another one. You said that the button is your second favorite HTML element. What's the first one?
I think the link, the anchor element, because it's absolutely perfect. You don't need to do anything to it. It does exactly what it's supposed to do. It points to another document on the internet. It looks right. The browser takes care of all the things like visited state, so you know when you've been there. You get the right-click context menu. That all this stuff that you can't recreate. You cannot create a custom link that has all the behavior of a proper anchor element. So it's my favorite for those reasons, but also because without it, none of us would be here. It's the element probably more than anything else that was first in HTML that created the web we know today. The ability to link stuff together is pretty much the main reason that the web exists, I think. So it's pretty cool.
Every person here clicked the conference site link before getting here, so that's literally true.
Right, exactly.
So we got here by clicking links.
Yep.
All right, you focused in your talk on button element,
Yes.
Just like an easy example of applying those principles. But what could be other examples of using, like maybe some range elements or pop-ups or anything like that? So just a few.
Yes, I think the dialogue element, it exists in HTML, but only Chrome supports it, and the way it supports it is not, in my opinion, particularly good for accessibility.
Oh, so the implementation of dialogue element is not perfect.
No, so Chrome is the only browser to support it. None of the other browsers do, so it can't be used really in production. It's one of the hardest things to get right from an accessibility point of view.
But if you're using it in Chrome, is it
if you use it in Chrome, it works, but their implementation, when a dialogue opens on screen, you need to move a keyboard user's focus to the start of the dialogue so that when they hit the tab key, they just start moving through the dialogue from a logical place. The thinking at the moment is that the best place to take that focus is to the container of the dialogue element, so that then the first time you press the tab key, you move to the first focusable element in the page, if there is one, in the dialogue, sorry.
Right.
What Chrome does is actually take your keyboard focus to the first focusable thing in the page, in the dialogue. And the problem with that is that if you're a screen reader user and the first focusable element inside the dialogue is the last piece of content in the dialogue.
Or closing button.
Right. But if the closing button's at the bottom and you've got a whole bunch of text and stuff before that, as a screen reader user, you've just missed it completely. So it's, yeah. So that would be a good use case for a good custom element implementation of a...
Have you seen any good custom dialogue implementations?
No.
All right.
There probably are some, but I haven't.
So it's up to you. You're developers. Go code it.
Tabs and tab panels would be my other one. We see tabs used all over the web, and they're hard to get right for accessibility too. So a good model for that, good custom.
There's a spec, but mostly it's not a spec. It's a collection of good accessible patterns. Is there tab panel implementation over there is good, or
No, so so the ARIA, you mean the ARIA authoring practices?
Yeah.
The pattern there is good. It works really well. I did work on a proposal to get some native elements several years ago now, but it didn't really go anywhere. But we did create a custom element implementation. Brian Cardell created that. But as I say, that was a few years ago now, and it's probably out of date.
Just like you said, it's out there. We need just to find it and use it. It's always a question of
or maybe write a new one.
Knowledge.
That one's probably
or
too
maybe
old
write
now,
a new one.
Yeah.
Okay, that's a tricky question. That's at least for me. Maybe you know. What's the best way to show loading progress for visually impaired people? Like spinner or even loading with progress?
The easiest way. So there is an ARIA attribute called ARIA busy, but it's not really, in my opinion, all that useful. A better way to do it, I think, is to use an ARIA live region. So you set ARIA-live equals assertive, and inserts a text message inside that container. So at first it might say, please wait, loading, and then as the page loads, it might say, thank you, page loaded. And as that text inside the live region changes, a screen reader will just automatically announce that text. No matter what else it's doing on the page, doesn't matter where it's focused, it will just say, please wait, loading. So the screen reader user knows immediately that something's going on. So
basically not showing animation, but telling that something's happening.
Yeah.
So that makes sense. What exploits may be identified after release of accessible object model, in your opinion? Like, what could probably go wrong apart from privacy, probably?
Privacy is certainly the big one that I mentioned. That's an interesting one. I think there is a possibility that with the ability to add things to the accessibility tree, you could create a completely separate interface for screen reader users that could trigger some behavior that you didn't want to. I don't know how that might work, but it strikes me that it would be hard for most people to detect if there was a whole UI that was only available to screen readers, that maybe asked you to enter some data, your password, your username, and then did something else with it. So yes, it's possible there might be more serious problems.
I heard a talk at Frontiers conference recently. That was a jam session. It was Sidetrack. There was a really little funny talk of there was a number of cases exploiting accessibility features for hacking, for fraud and things like that. So they usually have accessibility features usually have on software levels or in browsers, they usually have deeper access. So it's easier to exploit them in nasty ways.
It is. I think the one thing that maybe protects us a little bit is that to make use of those exploits, you've really got to understand accessibility and accessibility mechanics, and it's not that big an audience you're going to catch, if that makes sense. So I think maybe it's a lot of work to target, a reasonably small number of people. And my sense is that people who run these exploits, they want to go for the mass population, the biggest numbers possible. But maybe I'm optimistic.
You believe in people.
I believe in fairies too. It's okay.
It's always good to have a good example in front of you, so it would make you feel like you're not doing something useless. Could you name an example of any project that was terribly accessible or not accessible at all and became accessible after adopting these practices? Oh.
That's an interesting one.
Something huge like BBC or I don't know, Facebook, but not. I don't think Facebook is not Facebook.
Probably the best example is the UK government.
All right.
So they used to have thousands of websites. They all looked different. They all behaved differently. Some were accessible, some weren't. And then in 2011, they decided to shut down about 1,500 government websites and replace them with the one we have now, which is just gov.uk. And the whole thing was designed on a set of design principles, and one of those design principles is that it should be user first and that everything should be accessible. And it really is. Even now, sort of 7 or 8 years later, there's a very high standard of accessibility that didn't exist in government before. But more than that, the whole site is very simple. It's very easy to use. I lost my passport earlier this year on the plane, so I got to Canada and suddenly didn't have my passport. So it was really stressful, and I went to the Gov.uk website to report it, lost, and I could do that, and I was stressed. It was 3 o'clock in the morning. I'd been up for 20-something hours.
Whoa.
And it was so accessible and so easy to use, and I've never been so glad that a website got it right. And what's interesting about that site is that it won a very prestigious design award the year it launched in 2012. And this design award in the UK is usually won by someone who designs building or architecture or fashion or furniture. And that year it went to a website that's really not that pretty. It's very, very functional. But they gave it the Design of the Year award because they said its design was entirely suitable to its purpose. And I thought that was pretty cool too.
Yeah, that's great. What is your role in W3C and how to get there?
How long have you got? So I have 4 different things I do at the W3C. I'm on the advisory board, which is a small group that advises the W3C organization on things like governance and strategy. To get there, you have to be elected by the advisory committee. The advisory committee, so W3C is a member organization. Your organization can join it, and when your organization joins, they get one position on the advisory committee. So every member organization has an advisory committee representative. So I also represent my own organization, and I got that by paying money and joining the W3C. I also co-chair 2 working groups. The Web Apps Working Group I co-chair with Marcos Caceres from Mozilla, and that's the working group that looks after all sorts of JavaScript specs like screen orientation, web manifest, web share, the push API, and a whole bunch of others. And I'm also co-chair with Tess O'Connor from Apple of the HTML working group, which has now a slightly unusual role in the W3C because the W3C and the WhatWG are now working together on the HTML specification. And so that working group sort of represents the W3C in that relationship. And I got there because I got asked, and I'm stupid, and I said yes. So yeah, that's probably not much help. The best way to get involved, though, with the W3C is to go and look at their repositories on GitHub.
Right.
It's very easy now to comment, to read specs, to give feedback, ask questions, suggest new features. If you do want to actually contribute some words to a specification as an individual, you don't now need to join the W3C. Your employer doesn't need to pay money and join. You just need to agree that the contribution to the specification that you make, you have no patent claims over and will never make any patent claims over. And the basic reason for that is that the W3C specs always have been and always will be available for everybody to use for free. You'll never have to pay to use a W3C spec. So when you contribute, you waive your right to charge anybody to use your little bit of it. And that seems fair enough to me. So yep, the GitHub repositories, if you're interested, that's the place to get stuck in and start commenting.
All right, probably the last question. What's the current? How do you feel about the current state of captchas on the web? Like the way they try to, the way they work, and what would be the perfect way for you?
So actually, the latest Google reCAPTCHA actually for me works well. I can just put a check in the box, and it seems to think I'm human, and it works okay. I don't like them, though. I don't think they solve the problem they think they're trying to solve.
I haven't seen a single person liking captchas, so maybe robots like them.
Yeah, and the problem is that again there's a privacy implication. the same heuristics that Google used to check you're a human are also pretty good at identifying how you check that box. Did you use a keyboard?
All right.
Did you use a mouse? Did you tap on it? How long did it take you? That varies, you know, for a whole bunch of circumstances. So there's a lot of information we're giving away about ourselves just in the process of doing that. So I would get rid of them quite happily. They're like carousels. I think somebody thinks they're really useful and important, but most of us don't.
But even for sighted users, carousels are just...
Yeah, they're horrible.
They're just horrible.
Absolutely.
So, but imagine there would be a task for you to create accessible captcha, or the one that easy to use, not that just relies on your behavior and try to analyze if you're a human being or some script, but the one that you should interact with. What would it look like?
I think the best ones are the ones that ask you questions.
Like human questions.
Yeah, human questions.
Simple.
Yeah.
All right.
Yeah.
And try to analyze your questions and things like that. Should it be in text or audio, or you get to choose?
You've got to choose because I would need something in audio because I couldn't see any pictures. I could read text, but if there were pictures, that wouldn't work. But then if you just had it in audio, someone who is deaf or hard of hearing, would struggle with it. Somebody who has reading difficulty might not want the text, but they might want to listen to it. So choice is always good. In accessibility and the web in general, choices are always a good thing.
That's a very good end for this session. Thank you very much.
You're welcome. Thank you. Спасибо.
And could you please select the best questions? I know it's impossible thing to ask, but
gosh.
Do you remember any?
I do.
Any good?
I do. I think probably the question about what would be good custom elements to make, so the dialogue tab panels, that one, I think.
There was one. Okay, so
they were all good questions,
we'll find this one and give it some prize. So thank you.
Thanks.